Hello and welcome everyone. My name is Mark Henry, and today we're going to have another Opmantek webinar. In today's session, we're going to talk about how to develop a strategic NOC service using Opmantek's commercial and open source solutions. So a few bits of housekeeping before we get started. We do have a pretty full house today, so all attendees are going to be on mute during the presentation, just so we don't have any background noise or interruptions. If you want to ask a question, please use the GoToWebinar's chat panel. So we have a couple people here with me that are working on bringing those bubble those questions up. We'll get those answered and addressed during the presentation. We will also have a Q&A session at the end of the presentation today. So if you'd rather hold your questions to the end, that's fine. A copy of this presentation is available in the GoToWebinar handouts panel as a PDF file. So if you want to grab a copy of that, feel free. Just a note for everyone, today's session is being recorded. It'll be made available to all attendees after the presentation. You can also find it on opmantek.com under the Learn section. We'll get that posted usually within 24 or 48 hours. So topics for today. Today we're going to talk about the differences between a traditional NOC model and a strategic NOC. We're also going to go into how you can develop a service catalog with measurable SLAs. We're going to talk about how to architect a solution for fast client onboarding and scaling. And we're going to talk about how to identify your fully loaded costs in deploying and growing a strategic NOC. So we're going to talk about manning, manpower, the costs of manning a 24/7 NOC situation as well. So before we get started, what we're going to do is I'm going to throw up a poll question for everyone. So if you could just take a moment and select an answer. We're going to let this go another 10 seconds or so. All right, 5 more seconds. All right, I'm closing the poll. Thank you very much for sharing. So what's the point of having, whether it's just even a traditional network operations center, or more importantly, a strategic focused network operations center? What it comes down to is the IT service management maturity model, which is part of the ITIL standards. And the concept that as you move up through these levels of performance, you're adding improved performance to your network, to those that you serve, and of course, you're providing much more value to your organization. A traditional NOC model really focuses around the level 1 and may move slightly into the level 2 of the service management maturity model. Moving to a strategic NOC absolutely moves you into a high level 2, level 3 area, and depending on the types of services you offer, the types of SLAs that you have in place, you may even move into a level 3/level 4 point, which is really positioning your organization, helping to manage IT as a business. So you're providing significant value back to your organizations. So let's talk a bit about what a traditional NOC model is and a strategic NOC, and kind of really focus in on the differences between those two. So in a traditional NOC model, you've really got the network operations center is embedded in the wider kind of network server application support process. So it's functioning as part of remote desktop patching, antivirus, system monitoring, system maintenance. You're configuring equipment, you're pushing it out to remote locations, you're making sure it's getting installed. You may be installing equipment yourself or swapping equipment out throughout its life cycle. the focus from a network monitoring or system monitoring side is really on equipment state, and this is often siloed between engineers working on networking equipment and engineers working on servers, and servers may even be further spliced out between big iron pieces of equipment like the IBM iSeries 7 and Linux devices separated from Windows devices, different ESXi engineers, etc. But you're really focused on equipment state. How much CPU is used, how much memory is used, how much hard drive space is available. And as a result, many times the fault response is reactionary, right? So a client experiences a problem, there's an outage, there's downtime, and the first time engineers hear about it, in many cases, it's someone opening a ticket or picking up a phone and calling in a problem. Now let's kind of do a compare and contrast with a strategic NOC model. So the strategic model is really about improving collaboration and response time between businesses. The first thing a strategic NOC does is it separates out the concept of performance monitoring, of application monitoring versus system maintenance. So those types of roles, the software patching, the hardware upgrades, the hardware swap outs and refreshes, that gets separated out into a separate group of people. They may work in the physical same space, they may be in the next cubicle over, but as far as kind of supervision and monitoring and who they report to and what their daily operational state is, they're separated out. So the NOC team are all about monitoring the systems, understanding the state of the applications, and being proactive as far as ensuring that those applications are up and running. And notice that I'm talking about applications because it's really about user satisfaction. Because when someone picks up the phone, they don't really care. They're not calling to tell you a router's down. They're calling to tell you that their VoIP quality on their GoToMeeting was horrible. Or they're calling to tell you that they can't get to their SaaS application. Maybe the internet's down. They can't get out to the internet. They can't do a Google search that they need to do. And so the focus at the strategic NOC is not on the equipment per se, but it's more on user experience, application performance, and making sure that the end-to-end quality of the network is good. A couple of key pieces of this, of course, you've got to have initial fault response, has to be automated. So rather than engineers having to go out and do just basic troubleshooting pieces, you've got to have some kind of automation layer back there that's doing basic troubleshooting, information gathering, maybe even remediation and fault response. You have to have some kind of self-service components so that the customers, and whether that's you're acting as a NOC for a managed service provider, or whether you're an internal NOC for a business and your customers are lines of businesses, self-service is a key. Your customers can come to some internal intranet, some external internet website, log in and see how well are their applications performing, what's user experience on different key applications, and they can gather information without having to pick up a phone and call the NOC and talk to an engineer. Another key piece here is that in a strategic NOC, the NOC is actively involved with DevOps, with application development, QA and testing, and deployment of applications. So the NOC is upfront and talking as part of any custom application, whether that's developed in-house or whether that's a custom app being developed by a third party. The NOC is involved in that conversation so they can understand how can they monitor that application, how can they ensure that that application's up and running and performing properly, how can they do synthetic transactions through that application, what kind of syslogs might be able to come from that application as well, and can that application perhaps even push events directly into the network monitoring system. And finally, the NOC maintains proactive communication channels with their customers and the lines of businesses they serve. And as a network engineer myself, having started and owned my own managed service providers, having been a network engineer for 20 plus years, I can't tell you how many times I've seen and worked with network operation teams where they never talk to their customers. They have a series of devices that they monitor. but they don't. There's not a proactive communication. It is vital with the strategic NOC that there is that communication. It doesn't necessarily have to be day to day, but it's definitely at least on a monthly cadence, if not on a weekly cadence, to say these are the types of problems we're running into, these are the challenges we're seeing, these are the trends of your applications and your user base, and this is where you might need to start making some investments for the future. So what are the benefits? Big things that come out of that, the 4 big ones, are reduced time spent on routine responses. Because the engineers aren't having to answer those questions about, hey, is my internet service provider meeting their SLA? Again, customers can log in to some kind of a self-serve portal. They can look, they can see that kind of performance. Are their internet SLAs being met? Are your SLAs for application uptime being met? Those types of things should be self-service. So the network engineers are not having to respond to those kind of routine responses or those kind of routine questions. There's an improved reaction time to user experience impacting faults. There are several different surveys that are out there. I've seen numbers anywhere from a 25 to about a 35% improvement in reaction time to user experience impacting faults. And that really comes down to the concept that because you're not just watching high bandwidth spikes on interfaces, you're not just looking at high memory or low memory usage on devices, you're actually looking at generating synthetic transactions, which are coming back and talking about user experience and saying, this is the response time, this is how much time it takes to log into this application, this is how long it's taking to save a 10 megabyte file to this remote storage position. You're comparing more user experience information as opposed to kind of the granular pieces that make that up. You also see, as a result of that, a reduced time to fault resolution. If you see the problem sooner, you can fix the problem faster. In many cases, if you can see the problem coming, you can actually put in place workarounds or fixes before the issue actually becomes user impacting. And finally, if you're being very proactive, if you're keeping track of the overall state of application health and user experience, you're able to track over time and predict outages and system degradation. A good experience of that might be just being able to look at memory usage by certain types of applications on different servers or server pools, and being able to predict using some kind of a trending and impacting software, when are we going to run out of memory? When do we need to either add memory to this server or perhaps make this a server pool, an application pool, and put it behind a load balancer, and then be able to provide support for a wider audience, or even reach out to your SaaS provider and say, hey, we need to have more resources on this application. It's not meeting your SLA. If you can track things over time and you can see the overall performance, again, of the application and see it from a user experience standpoint, you can predict those outages, you can predict those degradations, and you can work on them, again, before they become user impacting. All right. Before we move on, I'd like to ask another poll. So if you do have a network operations center, or if you don't have one currently at your current employer, if you've worked at a business before that had a network operations center, was it a traditional or strategic network operations center? Was it some kind of combination of both, or was it something completely different? Was it neither? So we'll leave the poll open again for about a minute. Let everyone get in and respond. All right, another 15 seconds and we'll close this poll out. All right. Thank you all very much for participating in that poll. Looks like about 50% came back and said that they worked with a strategic poll, and the rest came in and suggested there was some kind of combination of both. All right, so developing a service catalog. So now that we've talked about the differences between a traditional NOC and a strategic NOC, let's take a look at what does it take to actually put together a service catalog. So a service catalog is really nothing more than a menu of things that the network operations center offers out to its customer base. And again, that customer base, if your NOC is servicing internal clients, lines of business, or whether that NOC is actually part of a managed service provider, selling services out to the public, whether those are businesses, small businesses, large businesses, enterprises, etc. So a direction that has worked very, very well for me in the past, and one that the Opmantek professional services team teaches in some of our on-site hands-on classes, is the concept of starting with multiple levels of application monitoring. So when you're talking to a line of business or a customer, being able to have several different levels that you can offer them, there may be a price or a cost involved with that. Again, if you're an internal organization, how that's priced out, how that's recouped, really depends on your internal accounting methodology. If you're a managed service provider, it's easy enough to assign a dollar amount to each of these levels based on the number of pieces of equipment that are included, the total value of the business, etc. We recommend at least 2 levels of application monitoring, but recommend a 3-tier system. The concept being, for example, that you might offer a bronze, silver, and gold level of application monitoring. And again, we're talking monitoring of applications, not necessarily of individual pieces of equipment. Those individual pieces will be monitored as part of that application value chain. But at the end of the day, what you care about is, are you delivering or that application in a way that meets the user's requirements? So starting off, you might say or define the bronze level as monitoring the underlying equipment and services required for applications. So you might be monitoring some routers, some switches, hubs, firewalls, load balancers, the servers that are hosting the application, servers that are hosting the databases. If you have a multi-tiered application, you might also be on the servers monitoring services like the MySQL daemon or SQL Server, etc., and making sure that those things are running, the Java virtual machine, etc., and making sure that those pieces of the puzzle are going, and defining that as kind of the baseline level. If you're running a traditional NOC, your baseline level may simply be ping monitoring of a piece of equipment. Does it respond to a ping? The unfortunate situation is an appliance that is completely pegged on memory, is struggling to get data through it. Maybe it's dropping lots of packets. There's lots of errors happening across it. May still have enough bandwidth to respond to a ping and say, yeah, I'm here. And yet it may completely be degraded to the point where nothing is passing, no traffic's moving through it. So much is being repeated that it's completely degraded the user experience to an unsatisfactory level. And so we don't even look at just ping monitoring as an acceptable starting point. So defining bronze, again, is monitoring underlying equipment, service, and any services required for an application. A silver level might be defined as everything covered by bronze, plus custom automated responses to defined faults. So what we mean by that is, if a node goes down, you lose communication with a device, you might execute a fast ping, you might execute a trace route against it, you might connect to other devices. If you can connect to the command line, execute commands, try to pull its current running configuration and store that as well. So depending on the type of device, you might run different types of traditional engineering troubleshooting commands on that device just to try to find out what's happening to it. And again, that would be based on both the type of device and the type of event that occurred. So I might define that as silver as my middle level. So I'm going to monitor the underlying equipment. I'm going to monitor the services required for the application, and I'm going to do some kind of automated responses for defined faults. You might also step that up a bit and say, what are faults that usually happen in your application? So we actually had one of our clients bring this to us just the other day. They do a lot of internal software development. Unfortunately, some of their software packages have memory leaks, and so as a result, they have some software packages that would eat up server memory RAM until the server went non-responsive. And so as users started calling in and saying, "Hey, I'm having a tough time opening up files or editing files or saving files," an engineer would go in and restart that service on the server, and that would free up the memory and things would go well. And so what we did with them is we worked with them to take that same approach. So we ran a couple troubleshooting scripts first, and then we would actually restart the service and then continue to monitor that service over time to make sure that the RAM on that server recovered properly. And if it didn't, then we could escalate that further and actually notify an engineer personally. Your third level, if you wanted to do a 3-tier system, might be a gold level. It would inherit everything from silver, which of course inherited everything from bronze. And you might add in synthetic transactions and deploying some kind of user experience monitors. So for example, if you have a multi-site office, maybe you have applications hosted in a data center here on the East Coast. You have offices in New York, you have offices in Chicago, maybe you have offices out in San Francisco, and they all access that application off your East Coast data center. So you might actually deploy user experience monitors in those remote locations, in your Chicago location, in your San Francisco location, that access that application, execute some kind of synthetic transaction, and it might be just as simple as loading a web page. Although frankly, if you can execute something more complex, load a web page, log into an application, execute some kind of a transaction, open a document, edit a document, save a document, exercise something through, let's say, a database layer, etc., the better off you are. And then you can actually compare the results from those remote monitors. Do your East Coast offices have the same user experience? Is the system as responsive as the people in San Francisco? Taking into account that you've got the whole speed of light issue between the East Coast and the West Coast of the United States, plus any internet layers that are in between there and slowdowns that are happening there. But looking at those two things side by side, are those acceptable? Is your system responding well? And then being able to provide that information back to your client, again, through a self-serve portal where they could open up perhaps some kind of a dashboard and compare and look at an application from multiple locations and say, oh, yeah, I can see how well it's doing here versus how well it's doing there. Another piece that might be part of your service catalog would be offering performance trending. Generally speaking, if I was putting together a NOC service catalog, I would actually roll performance trending into the gold level of application monitoring. But I've had several customers come back and say, I think that really ought to be an upsell. That should be something completely separate. And so we offer that here this way. How you put together your service catalog is completely up to you. But for performance trending, the concept is trending the underlying equipment to understand the user experience impact and investment needs, right? So you're looking at all of the bits and pieces. You're looking at interface utilization, bandwidth utilization. You're looking at CPU utilization on those servers for those applications, memory utilization as well. And you're trending that over time. And it's not just about looking and saying, what happened yesterday or last week? It's about looking at windows of time. How well does my application perform on a Monday morning at 9 a.m.? What's normal and where should it go to? Where should it be? What should that look like? So it's looking at windows of time to understand not just kind of homogeneously, one day versus one day, but it's hourly windows, at least hourly windows, day by day throughout the week to understand what the load on your your equipment is from supporting those user experiences. And again, the last piece of that service catalog might be offering a self-service portal to your customers. If you're a managed service provider and you're selling this out, you might give a self-service portal away to certain high-value customers. You may charge for it for some others, or it may be a full charge service that you have. Again, depending on how you want to monetize that, totally up to you. But generally speaking, it can be a tremendous differentiator between your service offering and some other third party. So even if you're an internal NOC, being able to offer self-service dashboards to your customers or your lines of business so they can see their application performance, huge. Again, it'll cut down inbound calls. And if every time a customer picks up a phone and calls you and says, hey, what's going on with my application? How come the widget application's slow? I can't open documents. If your engineer just kind of slightly nudges them and says, you can see that yourself. You want me to help you log in, or do you want me to just answer your question? They can actually help direct the customer to understand how to use those self-service applications as well. So now that you've got a service catalog, you've picked out what services you're going to sell, what service level do you offer? So I hear a lot of customers say, "Oh, well, we offer 99.9999% uptime. We're perfect." That can be excruciatingly difficult as well as costly to provide. So just taking a quick look at the little chart that we have here. If you were a business that ran 7 days a week, 24 hours a day, and your network has to be up 24 hours a day, 7 days a week, an SLA of 97% uptime would still mean that you would anticipate 1,300 minutes of downtime a month, meaning 263 hours per year of downtime. If you went all the way to a 99.99% uptime SLA, your customer would still experience up to 4 minutes of downtime a month, or about an hour of downtime a year. But the cost of that is like a hockey stick. The closer to 99.99% you get, the closer to 100% you get, the much higher the cost of delivering that solution are. So the questions that you need to ask yourself, but also ask your customers are, how much downtime can your customer absorb on a daily, weekly, monthly, and quarterly basis? Are there certain times of the day, days of the week, etc., where downtime affects the business income more? And what does that impact look like? Just to give you guys an idea, the ITIC's 2016 survey, 98% of respondents said an hour of downtime cost at least $100,000. Just 1 hour of network downtime, $100,000. 81% of the respondents said an hour of network downtime cost at least $300,000 an hour. And 33% of respondents said an hour of network downtime can cost anywhere between $1 and $5 million. So depending on the types of technologies your company uses, how much you rely on your network, on your enterprise network and the applications, and of course even what applications you're talking about, you really need to have that kind of a conversation with your customer, your line of business, to understand how important it is to them. And that also helps you line up your ability to be able to either acquire the equipment and manpower you need to meet the SLA that they have to have, or for managed service providers providing out to third-party companies, being able to tie those two things in and simply say, if you want us to guarantee a 99.0% uptime, then this is what it's going to cost you, because this is what it would cost you if you lose that time. A few other things that you want to take into consideration when defining your service level agreements is not just your hours of operation, how many hours per day, which days of the week, not just identifying what applications would fall within what SLAs, but also defining your fault and problem response time. Generally, that's defined as first touch, not resolution of the problem. It becomes very, very difficult to guarantee a resolution window, even in cases where you have hot swap equipment on site. You may have engineers on call or engineers up 24/7 who can get in a car and drive to a location and run down a hall and open up a server closet. Generally speaking, it becomes very, very difficult to guarantee problem resolution time, but you can definitely kind of give a window depending on your manning to fault and problem response time. Okay, so let's talk about how to architect that solution. So looking at Opmantek's network monitoring solution set, we have a large solution suite, many different products within the product portfolio. Opmantek owns all of the intellectual capital, all of the IP for all of the products we have, whether they're open source or commercial solutions. First thing I want to put out there, you can absolutely deliver a strategic NOC type solution using Opmantek's NMIS free and open source product. So you can do it. It's difficult. You cannot deliver it to the level of fidelity necessarily that I would consider a fully operational strategic NOC, but you can do pretty well. There will be a lot of heavy lifting that people will have to do. NMIS does not handle automated events response. It does some very basic event connectivity as far as understanding how devices respond to each other, which devices require other devices in order to operate properly. So as a starting point, you would start with NMIS as the core performance and fault monitoring solution. That'll also handle all of your thresholding. It'll handle your SNMP polling, your WMI polling, your SNMP inbound events as well, so SNMP traps. We would recommend that you add to that several of our commercial solutions. So you might want to expand that out with Open Audit Enterprise, which gives you scheduled discovery and auditing. So if you're monitoring remote client sites or departments where maybe your group isn't responsible for rolling new devices out, you may want to be able to audit that subnet and make sure that if the client deploys new equipment, new servers, new routers, that you identify those, that you get those rolled under your plan. And of course, again, if you're a managed service provider dealing with a client, they may hire an outside entity. They may run down to Best Buy, or they may get online and order a server from Dell or from HP, et cetera, and roll a new piece of equipment out. So having Open Audit deployed, being able to audit those subnets and identify new devices, then be able to add them into your monitoring system, very important. Depending on the number of devices you have under management, or depending on how geographically separated you are, you may want to be able to scale the system horizontally as well as vertically. So adding in multiple polling servers, maybe down at client sites, at remote offices on different floors in your building to handle different subnets, or just being able to deploy polling servers within DMZs. So you might have a PCI DSS DMZ, and you don't want to be able to poll into that DMZ. So you might want to be able to put an NMIS or NMIS server inside the DMZ to poll devices locally within that PCI DSS DMZ, and then push the results of that polling out to a master server. You may want to add OP charts. So we talked about the idea of self-service portals. With OP charts, you can create customer portals with customized dashboards based on individual user login. That can all be driven by LDAP if you want to. Very, very customizable. And again, you're looking to provide the customer, your end client, with the ability to self-service as much as possible. And OP charts is a key component of that solution. You can do some of that with NMIS, but it's not as pretty, and you can't control the user experience as much. You'll also want to look into perhaps licensing OP events. OP events claim to fame is not just the ability to deduplicate, to handle event storms, but to be able to whitelist and blacklist events, to be able to handle automated event response. So again, the example I gave earlier, where you might have a problem with an application using up too much memory, and not only can you run some troubleshooting scripts on that server, but you might be able to restart the service. You might be able to restart the server itself. You might be able to switch the load to another server even. So a lot of different things that you can do with OP events. If you can imagine it, if your network engineers can get onto a server and execute a command line or execute a program, you can do the same thing from OP events based on a series of events that happen. And of course, you might want to add in OP trend. So if you want to do trending and analytics, you'll want to add in that piece again. And all of these pieces plug into NMIS like spokes on a wheel. So if you consider NMIS the center of the hub or hub of the wheel, all of these pieces plug into it like spokes. We're often asked about equipment sizing. So if you're looking to use NMIS for performance and fault monitoring, an individual server, and now I'm talking a virtual machine, you can absolutely deploy to dedicated piece of hardware, no problem with at all. Or you can deploy to a VM. We support both directions, whichever way you want to go. You do have to have a 64-bit Linux platform. But if you have anywhere from 6 to 8 virtual CPU and 16 to 24 gigs of RAM, you can support somewhere between 3,000 and 5,000 devices on an individual server. So give that a thought for a minute. 8 virtual CPU, 24 gigs of RAM, 5,000 devices. Your biggest key constraints there really on how many devices an individual server can support really comes down to the total number of interfaces being collected, and that's completely controllable and configurable through NMIS's GUI interface. Your device latency and response time, so how long does it take the devices that you're polling to respond to those polls? And finally, and actually I consider this the key piece, is the performance of the storage system. So you have to have really fast read-write performance to your storage medium. We do recommend dedicated storage rather than shared storage, and certainly local storage over remote. So what do you do if you have more devices than an individual NMIS server can support? Again, look to licensing Opmantek's OPHA module. It allows you to connect devices together horizontally, so you can deploy multiple polling servers. And then you can add a second layer, a second horizontal layer above that with one or more master servers. A key piece here is when it comes to licensing Opmantek's commercial modules, we don't charge by the number of servers, we actually charge by the total number of devices under management. So whether you have 1 polling server or 10 polling servers and 3 masters, it's still the same price for the total number of devices under management. So what does that look like? The concept here is you could have multiple polling servers. That's at the bottom of the screen. They might be reporting up to 1 or more master servers. You might even have a master server designated as a portal server for your clients to log into. The concept there is that if a client has devices that are being monitored by multiple polling servers, they can see them all through a portal server located at that kind of second tier master level. Had a client the other day ask, "Oh, do I have to have 2 masters? I only want 1." Absolutely not. 1 is fine. You can do everything with 1 if you want to. In fact, if you can do everything with 1 server, you don't have to have a multi-tiered architecture at all. You can just deploy 1 NMIS server and load whatever pieces of commercial modules you want on top of that and go for it. It really just comes down to if you want to have, let's say, some kind of DNR support, you might want to have a second master and hot standby at your DNR location that's always up to date, always has good information, so it's kind of running hot, and then you can just switch over your URL to that master. You may want to have 1 master server on the East Coast, 1 master server in Bangalore, for example, if you've got a big engineering team over in India. And that way the team in India can have a really good user experience, because as they're accessing their local master server, they get very fast response times whereas maybe your East Coast US NOC site can have very fast response times by having a master server local on the East Coast of the US. So just some ideas. And of course, these could absolutely be deployed into the cloud if you want to. We have several clients who deploy their polling servers locally in their data centers and then put the master servers out in the cloud. Bit more detailed drill down into applications, how applications talk. You'll see at the bottom of the screen where it says subnet, those are all the devices that are being monitored. That's not just devices, that's applications as well. So you'll see over on the left-hand side there where it says service monitor. So coming right here. So not only are we doing SNMP and WMI polling, NMS is also doing service monitoring as well. So it's monitoring services, whether that's generating synthetic traffic or just loading a web page and trying to figure out how much time that takes. So how do these different pieces fit in, right? So as I mentioned earlier, OP Charts, not only does it provide a really rich user experience, you can create custom dashboards for your own internal teams, for your NOC. You can have custom dashboards that go up on the wall. You can have geographic maps driven by Google Maps. You can have topological maps of devices. You can have all kinds of charts and graphs, combinations. You can actually pull in information from our configuration compliance management system, OPConfig, about configuration changes happening on the network. You can pull in information about events happening across the network and have dashboards for your events as well. But one of the key pieces that I like when it comes to providing a NOC service is the concept that you can also use OP Charts to provide that customer portal, right? That idea that a customer can log in and see exactly what's happening on their application. And let me just switch over for a moment. I'm just going to flip over here to a little demo application that we put together. So you'll see at the top center here, we have a topological map. And this just happens to be the value chain of, in fact, this demo server and the very demo that I'm giving you today. So we have an ESXi server, Odin, on the far left. It has a yellow background, so it's degraded, and I can click on that and drill into that and understand why. Next to that, we have demo, which happens to be the demo server. It's a Mac Mini. We've got the interface between the demo server and the Gold Coast router. So our demo server is actually in the Gold Coast, Australia. And then we have the connection from the Gold Coast router out through the VPN into the internet, and then down from the internet to the Charlotte switch here in Charlotte, North Carolina, and then the connection to the Charlotte server. And you can see here that my local server is actually powered down. So we've got a red background, so that server is actually down. So I've got a nice little topological map here of again, that application value chain. Below that, in the center of the screen, you'll see we have an OMK service status and response. So OMK is short for Opmantek. What I'm actually doing is I'm measuring the load time on a specific test page that we offer in our application suite. And what that test page does is it actually runs a test on the database and makes sure that the database is up and running and working properly. So I've got the load time on that web page in yellow or gold, and then the black line here shows 100% uptime on the application itself. At the very bottom, I have my internet traffic through various different interfaces here, both on the Gold Coast and also on that demo server. And then down the right-hand side, I have several different monitored services. I have some interfaces that are down here, so I can keep track of the different interface, speed, usage, input, output, operational status, admin status, and then the various devices that I'm concerned with, Odin and demo, down here on the right. You can create whatever kinds of charts make sense to you. This works for me as a demo, works for me as an engineer. I might make a slightly different chart for some of my clients. You can create whatever you want. You can make them available to different clients. You can assign them to clients, and you can restrict which devices and even down to which interfaces clients can see. So we talked briefly about the concept of adding in trending and analytics and making that a service that you might provide in your service catalog. So I just wanted to give you a quick insight into OP Trend, which is Opmantek's trending piece. We actually use a 26-week SEDS calculation to look at not only day by day, but every hour in the day, as well as how an individual device is working. So you can see, for example, over here on the left-hand side, we have what we call our billboard. This happens to be CPU load over this time period. And so for one of our servers, we have a very high CPU load at that time. It's been in the billboard for 7 weeks. If I drill into what that actually looks like, you can see these purple bands show CPU usage that exceeds what is normally seen. So these blue lines that are here are actually a standard deviation. So this is 3 standard deviations for what's normal. The green line that you see here, that green line is the average. That's the normal seen. And then the blue lines are, again, 3 standard deviations from the norm. So anything that exceeds those 3 standard deviations is considered an outlier, something that's not normal, that's outside of accepted standards or norms, and can generate its own event. So you can use OP Trend not only to keep track of how well devices are performing over time, how they're loaded at certain times of the day, days of the week, but you can also use it to actually generate proactive alerts to your system to tell you when usage is outside of normal. You can use the same system to track CPU, memory, and bandwidth usage on all of your tracked interfaces. So if bandwidth usage goes above or below what's normal for that interface, for that hour of that day of the week, the system can tell you whether it's exceeding or if it's dropped below what's an acceptable window. So some things, some thoughts for you as you're looking at client onboarding. So how do you reduce friction, automate where possible, and document everywhere, right? How do you onboard new clients? So a few thoughts here. Are new clients added to existing polling servers, or are new servers, or will new servers be provisioned, right? In many cases, we recommend with managed service providers that if you can, you deploy a dedicated polling server at the client site, let it handle everything within the client, and then push the results of that up to a master server at your NOC site. We do have some very, very large international multi-continent managed service providers that use our solutions. And in many cases, they'll have 10, 15, 20, even as many as 50 dedicated polling servers in their NOC site reaching out to their clients. For clients that have high latency or poor internet connectivity, they'll deploy a polling server on site with those clients. But in many cases, they're just deploying the polling servers either regionally, geographically, or keeping them within their NOC center. So you want to take into account how are you going to respond to that? How are new devices and services added to the polling servers? What's the process? What's the documentation? What are the questions you have to ask? Is that part of the sales cycle? Is that part of the management cycle? Is that something that's handled by engineers? Who has that conversation? And then, of course, is the service charged back to the client? When it comes down to bringing on a new client, you definitely want to understand what applications are key to their line of business. You want to understand what services need to be monitored and what SLAs you need to offer for each application. So some clients are going to come in and tell you, oh, we absolutely have to have Microsoft Word. It has to be up 24/7, even though we're a business that runs Monday through Friday, 9 to 5. So the question really is can they pay for 24/7, or do they want to support 24/7 monitoring? And is that application something that is actually really critical? If that application goes down, what's the impact of the business? Again, what's the cost? And finally, if you are monitoring an application and you are offering that gold level with synthetic transactions, what types of transactions will the application support? So many times we'll pick up the phone, we'll call a kind of a shrink-wrapped application company and say, hey, we're working with such and such a client, they're using your application. Is there any way when we're monitoring that application that we can generate a synthetic transaction? Is there some kind of a test command that can be sent to that application? Is there a command line interface that we can use? Is there a web page that we can interact with to gather information? All right, last but not least, let's talk about how to identify your fully loaded costs. So a lot of discussion around this piece all the time. You know, if you have different calculations, different ways of generating what your fully loaded employee cost is, go ahead and use it, right? These are just kind of generally accepted industry norms. So generally speaking, if you start from an employee's annual salary, if you multiply that by 1.49, SAP uses that metric, the 1.49 multiplier, in their calculations for a fully loaded cost. Others that we've read about go as high as 2.34 times the annual salary, and 2.34 is actually calculated from 1.25 times to calculate employment taxes and benefits, 1.75 for office space and equipment, and then 1.25 for related management expenses and non-billable work. So keeping those kinds of numbers in mind, here in Charlotte, North Carolina, a network engineer 2-3 position would be an annual salary of about $89,000 a year, which would, if you do the 1.49 SAP multiplier, would be a fully loaded cost of $133,000, or if you go to the high end at 2.34, would be a cost of $208,000. Now, in order to staff a 24/7 NOC, we kind of apply several different assumptions here. So right off the bat, if you want to apply a 24/7 NOC, you need at least a single engineer to support upwards of 8,000 to 12,000 devices in a shift, right? This assumes that the system is properly configured and load balanced, right? So you have NMIS, OP charts, OP events, OP config, and OP trend. Everything's installed, it's configured properly, and all the users and the administrators have been trained. That number, the ability for one engineer to support 8,000 to 12,000 devices, also assumes that you've automated the ability to add, update, and retire devices. So you don't want your staff engineers having to add devices to the system, remove devices. They may still put devices into outage, right? That doesn't necessarily have to be automated, although that certainly helps. But having that kind of basic add, update, and retire automated through whatever CMDB you're using, whether that's open audit or a third party, that's also kind of an assumption in that 8,000 to 12,000 devices per engineer. This also assumes at least a silver service level. So you're providing monitoring of underlying equipment and services required for an application, and you have custom automated responses to defined faults. So you've got those pieces in place. And of course, it assumes normal operation. So, if you're in the middle of a hurricane and you're still trying to provide services, you may want to have more than a single engineer on service. So our recommendation in order to staff a 24/7 NOC, if you have 2 engineers per shift, that comes out to be 9 full-time employees in order to no engineer working more than 40 hours a week, etc. 50 weeks a year, 2 weeks of paid vacation. You need 9 full-time engineers. That comes out between $1.2 and $1.8 million a year as a fully loaded cost to staff a 24/7 strategic NOC. Keeping in mind, again, that that's not just the cost of the employee, that's their space, that's their hardware, that's their software to provide that 24/7 NOC. Last piece I want to touch on, we brought up the concept of different SLAs and what that costs, right? So if you're starting, most businesses are starting at an SLA of about 97%. That gives you 262 hours of downtime. So if you implement all of Opmantek's solutions, so that's NMIS, OP charts, OP events, OP config, OPHA, and OP trend, you can reduce your downtime by an average of 68%. So that takes you effectively from 262 hours of downtime to 84 hours of downtime a year, or from 97% to 99.0% SLA. In a $150 million a year business, that creates a savings in revenue and productivity of about $2 million, which, if you go back to what it costs you to put together that 24/7 NOC, covers your complete cost of the NOC. All right, everyone, that concludes our presentation for today. I'm going to turn off recording at this point and then open the floor for any questions.